Hello and welcome to this session of Introduction to Autonomous Systems. In the last segment, we talked about blind or uninformed search techniques and came up with some benchmarks which would tell us which is likely to work better in a given context. As against those, let us now look at informed or sometimes what is called heuristic search methods, where apart from the problem definition which we already have, there is additional problem specific information which is also available, and now that is what makes it different. Now, in such cases when there is problem specific information available, it is possible to simplify the search methodology and arrive at the solution in a more efficient manner, which means we can reduce our search time. Like I mentioned in the previous segment, that in case you know that you lost something in a particular specific location, it is a problem specific information that you are making use of in order to simplify your search in a more efficient manner. Informed search strategies or heuristic search strategies are essentially these kind of strategies that use problem specific information to drive search algorithm and can generally find solution more efficiently. So, these strategies most commonly employ a technique of best first, in which expansion of a node is based on the minimum or the best value of a cost function, and immediately you realize that this is also indirectly trying to get the optimal solution, but we will talk about this a little later. At the moment, let us just accept this idea that this is the best first, that whichever has the least cost you expand that node. And in order to do that, the tree or the graph search algorithms are augmented by a function f n, where n is the identifier of that particular node, to help expand the node for searching the solution. This function f of n is typically called evaluation function. It is almost somewhat like a cost function. So, the lowest value of this function is used to start the search algorithm. In fact, this function f is in general a heuristic function h, which is defined as the estimated cost of the cheapest path from state at node n to a goal state. Such heuristic functions include the additional knowledge about the problem, which helps the search algorithm to find applicable solution in an efficient manner. In terms of their attributes, heuristic functions are taken to be non-negative, arbitrary problem specific functions with the only constraint that if n happens to be the goal node, then h of n will go down to 0. So, it is almost like searching for a minimum or a 0 potential solution, and h of n almost mimics a potential function. So, when the potential becomes 0, you have reached the solution level. So, there is now an alternative which is called the greedy best first search method. Now, in the greedy best first, we expand the node that is closest to the goal node based on the premise that it will lead to the solution quickly. Now, if you look at the previous one, it was based on the minimum cost, but now we are saying that the node which is the closest to the goal node will be chosen to expand. Now, the method evaluates each node based on the value of the heuristic function h, and it could be as simple as the straight line distance to destination in case of mobile robots. Suppose you have, or any travel related route planning, path planning problem if you want to look at. This would be just, let us say, a straight line distance between the 2 points, or what typically sometimes people call at the crow flies. So, let us now take the same example what we saw in the previous session of going to Bucharest in Romania, and I want you to look at this table. Now, this table is giving the distances of all the locations from Bucharest. As you can see, the Bucharest, which is the goal node, has been given the distance equal to 0. So, that becomes your ground point, and then you have a large number of locations whose distances or the straight line distances are specified. The idea is that can we now set up a greedy first strategy that would give us a path from Arad, which is 366 kilometers away from Bucharest, to reaching the destination using whatever the intermediate, and to do that we need a kind of a conceptual map of this segment of Romania. So, this is that partial map of Romania where you have, now you can see that there is Arad, and the straight line distance from Arad to Bucharest is given. Please note, the straight line distance is only an approximation, because the actual distances will depend upon the nature and the way in which the alignment of the roads which have been created. Now, the map actually shows the straight line distances again between the individual destinations. So, you have from Arad there are 2 successors, one is Sibiu, other one is Timisoara. Then from Timisoara you have only a single path until you reach Craiova, where again you have 2 successors, and similarly if you go to Sibiu then you have 2 successors, and if you go to Pitasi then you have another 2 successors. So, you see that this is the way now the whole thing has been organized. Now, let us look at how the greedy best first strategy would expand the nodes. It will first start with Arad, look at the cost of what are the various successors and their distances to the destination, and you find that the lowest distance is Sibiu. So, you latch on to Sibiu. Now, then you go and look at all its successors. One is going back to Arad, which obviously is of no use, which is also largest cost. Now, you have Făgăraș from Sibiu, which has a cost of 176, which is the lowest. So, you now take Făgăraș from Sibiu, that route you take, and then you look at from Sibiu, and again you find that from Făgăraș the Bucharest is direct distance, there are no more successors except the goal node, that is Bucharest and 0. Now, if you add now the cost of these, that is from Arad to Sibiu, Sibiu to Făgăraș, and Făgăraș to Bucharest, that would be the shortest and the best path that one would take. Even though we say that the straight line distances are only an approximation and that there could be some correction, you have to note that straight line distances are also in some way related to the actual distances. So, they are reasonable indicators of the actual distances, and in the process they will represent the solution which will essentially be correct. So, to conclude this part, informed search techniques make use of additional knowledge of the problem in order to reduce the search space as well as the search time. Also, there are many practical scenarios where the search has to be an online and real time activity. We will talk about these as we continue with our discussion on the search strategies. So, with that we come to the end of this session. So, bye for now, thank you and see you in the next segment.